All right, everybody, welcome back. Again, we're going to continue our conversation talking about solubility. This particular video, first and foremost, is going to be really short. All right, it's literally this slide and then one more slide after this. I'll do a couple examples just over this video here, but then obviously in class, we're going to be doing a lot more examples in class itself, just to make sure you guys have a good grasp of it. But yes, this will be a short video. Number two, this particular video is really going to aim to help alleviate any issues you guys might have on the current lab right now, the lab that we just did, ions in solution, all the solubility issues, talking about precipitates and what precipitates, what has no precipitate, all that good stuff is going to kind of help get covered in essentially in this video here. Okay, so without further ado, let's talk solubility rules. So for some solutes, it is convenient to characterize them as either being soluble or insoluble, right? It's not always going to be whether or not they're saturated solutions, unsaturated, or supersaturated. Sometimes it's just way easier to talk about whether or not they're soluble or insoluble. And we're going to use a new table. I know we just, excuse me, just introduced table G yesterday, which is the solubility curves. This right here, table F, is more of an identification table that helps you look at any given substance and helps you determine whether or not it's soluble or insoluble. Now, the only catch here with table F is that there are going to be some exceptions to this, and you'll see how those exceptions play out. Now, any substance that is considered to be insoluble is also going to be called a precipitate, right? So that's why we used that word precipitate in lab the other day. Excuse me. So we used that word precipitate in lab the other day because if a substance was not being dissolved into the water, it was just represented as a solid that was being in the water essentially, right? And that solid substance that you would see, or maybe the cloudiness or the dots or whatever you saw in your little mini reactions in lab, those were actually going to just be your insoluble substances. Now, solids are generally more soluble at a higher temperature, and gases are generally more soluble at low temperature and high pressure. And if you ever thought about it, okay, whenever you crack open a can of Coca-Cola, for example, all those bubbles that are inside of your Coca-Cola can, that's dissolved CO2 gas, right? Carbon dioxide. Well, that carbon dioxide gas is literally dissolved into your beverage, right? Your Coca-Cola beverage. And so, you know, it's no wonder that we like our carbonated beverages to be cold, right? That's why they sit in the fridge. And, you know, if you ever noticed that once you crack open that can of Coca-Cola, and let's say you leave it out, right? You leave it out in your kitchen or wherever, right? You leave it out for an hour, right? It has a lot of time to warm up that Coca-Cola can. And you come back and you take a sip of it, all that carbonation is essentially gone, right? Because the solubility of that gas likes to be at lower temperatures and higher pressure. As soon as you crack open that can, you're starting to increase the pressure and increase the temperature and lower the pressure, which is exactly the opposite of what gases want to be soluble in liquids. So that's kind of some of the rules behind solubility. Now let's get right into table F here. Okay, table F is really important. Again, it's super useful not only just for this current lab that we're on, but just for knowing how to determine if a substance is going to be soluble or not. First things first, whenever you look at a substance, you want to be able to identify the cation and the anion, right? The cation being the positive ion and the anion being the negative ion, right? So let's say, for example, we are dealing with the substance, I'll write it over here, NaCl, right? Classic example, right? NaCl. Well, you look at a substance like this, and the question might just read, is NaCl soluble or insoluble in water? Well, you have to do a couple of things. First and foremost, you have to look at this substance and say, well, what is the positive ion and what is the negative ion? Okay, and this is going to draw on some of our skills that we previously learned way back in chapter 5. Okay, so just by breaking this down, we know that Na is a +1 and that Cl is a -1 ion. Okay. Again, if you want to be very specific, you shouldn't actually obviously have the ones there, right? So we should have just the plus and just the minus signs there. Okay, so Na plus and Cl minus. Right, that's step 1. Identify your positive and your negative ion. Step 2, try and find the anion first. Okay, look for just the anion. I'll circle that a little bit better. Okay, just the anion. So we look at our two ions here. Our anion is Cl minus. So what we need to do is go look at this table here. I usually like to always start way over here with the soluble, with the compounds that form as soluble, and then move over to the other side, the right-hand side. Okay, because note how it's a two-sided table. This side is talking about soluble compounds, and this side is talking about insoluble compounds, right? So I usually like to start with the soluble compound side. So we start out right here. Is our Cl minus a group 1 ion, like lithium +1, like Na +1? No, it's not, right? So cross that off and move on. Next, is our Cl minus ion aluminum? No, it's not, right? Or ammonium, sorry, NH4+. Nope, definitely not ammonium, so we keep moving on. Is Cl minus nitrate, NO3 minus? Nope. Is our Cl minus the same as acetate, which is C2H3O2? Nope. So keep moving on. Is Cl minus hydrogen carbonate? Nope, it's not HCO3 minus, so we keep moving on. Is our Cl minus ion chlorate, ClO3 minus? Nope. Lastly, or second to last here, halides. Is our Cl minus a halide, which is a Cl minus, a Br minus, or an I minus? Oh, look at that. Yes, it is a halide, right? We see our Cl minus as an option right here. So before we do anything, so far we can determine, since our negative ion, our anion, has appeared in the soluble compound side, we can determine that our compound NaCl as a whole is soluble in water. But this is where exceptions come into play. Now, all of the different pieces we've seen so far, like the group 1 ions, the ammonium, nitrate, all that stuff, okay, they have not had any exceptions. But now if we look here, our halides absolutely have exceptions. So the exception is our Cl minus is soluble, our halides are soluble in water, except when combined with Ag +1, Pb +2, and Hg2 +2. Okay, so my question to you now is our current Cl minus bonded to an Ag+, Pb +2, or Hg2 +2? No, it's not. We are currently bonded to Na+. So we can now label our NaCl as soluble. Soluble. And that's kind of how it works. Okay, so you go down the line, you always try and identify your anion first, your negative ion first, and then use that to try and help you determine if something is soluble or not. Okay, and that's generally how it goes. Thanks, guys.